Hey, good morning, everyone. From today onwards, we will discuss about the service-oriented architecture. We'll take a minimum of 5 to 6 lecture regarding the service-oriented architecture, which is used in the grid and cloud computing. I'll start from the basic perspective. I'll tell you some of the issues and challenges with respect to the service-oriented architecture. So this is the things we are going to discuss about the service-oriented architecture. We are focusing the service-oriented architecture for distributed computing because you know that the cloud is distributed computing. First, I will tell you about what do you mean by a service, okay, and I'll tell you what do you mean by a web service, which is represented by WS, and I will tell you about the service-oriented architecture and I'll tell you how these services are related to the service-oriented architecture, what happened in the traditional system, what happened in the service-oriented architecture, what are the lacuna in the traditional architecture which is improved in the service-oriented architecture that we'll discuss. Then I'll tell you about the message-oriented middleware. I told you middleware is used to reduce the complexity of any infrastructure, and middleware also provides a single system image, we have seen in the grid computing. Next, we are going to see about various portals and the science database used by various universities in various projects also. We are using several portals and how these portals are related to the service-oriented architecture. Then I will tell you about something called as UDDI. You may have heard about UDDI. That is nothing but a registry, and you will see how metadata is managed, how you can relate one service with another service, and how the database is managed in the service-oriented architecture. And lastly, I will tell you that workflow used in the service-oriented architecture. In software engineering also you have seen the workflow, how you are starting with a project, which module is dependent on which other modules, how the modules are incorporating each other to get the services. So for that, a workflow is managed, right? Whenever we are designing a particular project, we are dividing the project into several modules, and each and every modules are related to each other, and their dependency and the type of data transfer, everything we need to represent graphically in the form of workflow. After the end of this one, I will also tell you about some of the realistic workflows used in the task scheduling problem. Like one of the problem is called as one of the real life workflows name is LIGO, LIGO, epigenomics, and another is SIPST. These workflows also will discuss in details so that the idea of workflow, workflow will be clear and in all the perspective. But in this module, we are only focusing on the what are the workflows used in the service-oriented architecture. So there are two major SOA styles are there, service-oriented architecture styles are there. One popular things is used in the service-oriented architecture that is called as REST. Maybe whenever you have studied about XML, if you have studied earlier about HTML, XML, PHP, these things, you may have heard about REST, which is called as representational state transfer. Okay, this we are going to discuss, and I'll tell you about the web service. Various web services is generally represented by WS-star. WS-star indicates that web service with respect to any domain, right? For example, in a particular case, we are saying WS with respect to, instead of saying star, we are going for a specializations, right? But in generalizations, we represent the web services by WS-star. And there are possible extensions, and with respect to the services, what are the things available, what are the web services available, that are also we are going to discuss. I'll also discuss about the two application interfaces. One is Open Gateway Computing Environment, very popularly called as OGCE, that we are going to discuss in this service-oriented architecture. Also, I'll tell you about the Hub0, one of the application interface, because whenever we are going to discuss about the portals and gateways, where we are getting the services or we are requesting the services, in that case, this OGSC and Hub0 plays an important role. And many universities also decided various application interfaces. Okay, that also we are going to discuss. Although all the application interfaces are not open source and they are not generalized to any type of services, but you can see what are the different examples with respect to the application interfaces. Okay, let us come to the first part. In first two class, we are going to cover about what are the various services and service-oriented architecture. If you have already, if you have knowledge about the Amazon S3, whatever we discussed, and last to last class, we have also submitted your assignment about Amazon S3. The more or less the same thing. I will take an example so that you will clearly understand what are the different services uh, available and how we can provide the services using the service-oriented architecture. So before the concept of the services and the service-oriented architecture, first you should understand what is the name of loop coupling. I told you earlier also there is something called as type coupling and another is called as loose coupling. Generally, distributed systems are called as loose coupling system because there is no dependency between one computer with another computer system, right? So what happens if a computer will fail, then it will not going to affect other computer systems, right? But if it is type coupled, then one computers if one computer is failed or the performance of the one system is degraded, then it is going to affect other systems as well. That's why loose coupling is adopted in the service-oriented architecture in order to avoid these things. But whenever we are talking about the loose coupling, you should make ensure that if different units are working at the same time, they should be available. The same data is available in each and every case. Where synchronization plays an important role, right? So whenever you also, we are in our day-to-day life also we are using Google Drive in our laptop, Google Drive in our mobile, Google Drive in our office computer. Anywhere we are maintaining the same Google Drive. So the main problem is that if internet is not there in which you are working, in which the computer you are working, so what will happen? The data is not synced to other uh, uh, with other devices, right? So what will happen? If you is the duplicate data is available in the devices, if you are not updating the data, it may not affect it to other data. So that there is a inconsistency may arise, right? So loose coupling and support of heterogeneous implementation makes service more attractive. The main thing is first service-oriented architecture is very popular because of this loose coupling concept and heterogeneous implementation. I told you heterogeneous implementation means the implementation is not a static one. It may vary with respect to the time. Heterogeneous believes in different architecture, different types of implementation, different types of hardware and software supports, right? So this makes more attractive within the distributed object. Whatever you have seen in Amazon S3, that is called as an object-oriented object, right? The object is based on the OP, right? Object-oriented concepts are used in the that object, right? So earlier, after that, there is a distributed objects are there in the distributed computing, but this can be more attractive by applying the loose computing and heterogeneous implementations. And coming to the definitions of SOA, you can say we are going to design a software system, right? Or we are asking how to design a software system that makes use of the services of new or legacy applications through their published and distributed interfaces. Each and every software system has an interface, right? Whenever we are accessing a particular website or whenever we are referring any application, see, each and every application is provided through an interface. So how you are going to provide a unified interfaces to access all the things? Okay, or you are designing a system which can provide all types of applications in a particular interface. That is the objective of our service-oriented architecture. So SOA is going to design or going to provide a software systems for such type of applications. So SOA aims to make service interoperability extensible and effective. So you know that if you take an example of, let's say, the online shopping websites, in the online shopping website, what happened? That the various vendors are there. Early days, when if you take an example of Flipkart, all the services are provided by Flipkart only. But nowadays, there are many stores that are attached to the Flipkart and Amazon. So whenever you are purchasing a product, you are not directly purchasing from Flipkart, or now we are not directly purchasing from Flipkart because there are many vendors are attached with the Flipkart. They are going to deliver such services, right? That's why some products we are believing that if it is a Flipkart assured product, then Amazon assured product, then we are saying that this product is delivered by Amazon, so it is a genuine product. However, if the product is given by which is not Flipkart assured, we are assuming that that product will be given, right? So such type of things, when you consider, then you can see whenever you are placing a particular order, then it will go to a particular software unit or department who is going to see whether your order is placed or not, whether your payment is done or not. Once the payment is done, again one request will come from the payment department to the verification department to the shipping department to ship your product and check the quantity of the product, whether the sufficient number of quantity is available or not. Based upon that, they are going to ship the product to you. Once the product is ready for shipping, again, if they want request is made from the initiated from the shipping department to the courier department or in the postal department to deliver this product to the customer's address, right? So you can see that while you are purchasing a particular product, there are multiple things are attached, right? Or multiple components are attached to. So what happens? Your request is moving from one unit to another unit in order to complete a particular process. So what SOA is going to do in this case? SOA is going to develop a particular software system so that these units can be combined. Okay, they may have coordinated each other so that all the services, all the requests should not be moving from one to one, or they may be implemented in the form of a workflow so that the same information, whatever is available, that will be given to all the individual units, and the complexity arises to different components can be reduced. That is the purpose of going to design a software system using the service-oriented architecture, right? So SOA is prompting to your rules coupling system, published interfaces, and standard communication model. So it is providing the standard communication model. So whenever a customer is submitted a particular product, it is going to deliver the product without moving from one department to another department, which happens in the traditional ways. But nowadays, online shopping websites, once you place the order, we are not going to check whether the product is shipped or not, or whether the product is available or not. Such type of things we are not seeing, right? We are only believing that the product will be delivered to us without moving from here to there, right? But earlier systems, the customer needs to keep track of these things. Now everything is available in your login. Once you give your username and password, so what you can do, you can get the details about a particular product, right? Although these movements is there, but the service-oriented architecture makes it simpler so that the customer should not be overwhelmed with the task which is moving from one component to another component. So worldwide, where consortium, which is popularly called as W3C, defines the service-oriented architecture with various properties. We are going to discuss the properties. First is they want to define the service-oriented architecture from the logical perspective, logical view perspective. In logical view perspective, they called SOA is abstractive. It is a logical view of the actual program, right? What we are doing, we are just creating a system which overcomes this complexity. That's why it is a logical view of the actual program. The program, the things, whatever you are doing, that is done. Okay, that is processed as for their sequence or as for their workflow. But what SOA is going to provide, it is going to provide the logical view. Okay, logical view of the actual programs, or you can say databases, business process, and so on, right? So we want to design a system in order to avoid this complexity, and customer did not bother about this particular thing, how this product verification is done, or how the product quantity, whether sufficient product quantity is available or not. Such things the user should not bother about, right? The services is defined in terms of the message exchange between the provider agent and the requester agent. One requester agent is going to request a request. We want to make a request to the provider agent, and the provider agent need to provide the whatever things requested by the requester agent, that you have to provide it, right? Both provider and requester agent can go for a standard communication protocol, or they can use a single system like service-oriented architecture in order to exchange the messages, in order to get the unified services using service-oriented architecture. Similarly, if you see the properties with respect to message orientation using the service-oriented architecture discipline, one does not or should not need to know how an agent is implementing a services constructor. You will not bother about, right, how you are going to implement a particular services, how the services is going to be rendered. Thus, such things are not the rule, are not required in the case of service-oriented architecture. Similarly, if you can see in the descriptor orientation, a service is described by machine executable metadata. You know that whenever the metadata is about data, we don't want to see the internal details of the data, rather than we are maintaining the basic properties of the data, which is called as our metadata, right? Like when you see in a particular folder, you have several files. So in each and every file has a name, each and every file has a size, each and every file has a read write permission, each and every file has has the length or the ownership. Lot of informations are there. These informations we want to keep in order to compensate. You have to see that the common properties of each and every files, right? So the service is described by machine executable metadata. We are interested in the metadata, not in the data. And you will explore the details to the public or to your agent, whatever the information you want to provide to your agent. That is not, you are not going to provide the complete information to the agent or public, right? That's why it is saying only those details are exposed to the public and are important for the use of the service should be included in the descriptions, right? The description says that if a user is ready with only the 10% details of all the particular thing, so you are going to provide only 10% of the information, not the complete information, right? So similarly, all the details of the data is not explored to the public or to the user. Those the user are interested in data, user can understand or user can ask the information about that particular data, that we are going to provide to the user. So here, if you see, granularity is coming into picture. I told you granularity is of two types. One is fine granularity, another is coarse granularity. In fine granularity, we are going for detailed view, detailed things, but coarse granularity, we are going to an abstract thing, right? So you should not always provide the information by assuming the fine granularity, maybe the detailed one. Sometimes the coarse granularity is sufficient to provide information to the agent or user or to the public, right? So granularity uses a small number of operations with relatively large and complex uses, right? So we are not going like many websites, whenever you are visiting, it is showing only 2-3 lines, then there is a show more option is there, right? So when you click the show more information, the detailed information is given, right? But if somebody is not interested for the to see all the details, so you can read first 2-3 lines and you can repeat with that 2-3 lines, right? So all the details you should not explore, right? Because if you details you can show, it will also may complex the entire system. The network orientation part also coming under the descriptive orientation, we use over a network, and we are also using the platform. Specifically in the service oriented architecture, we are using extensive markup language, that is XML, right? For writing the request or writing the response, we are using the XML system. So here you can see, I told you that is REST is used, REST is used in the case of service-oriented architecture. So you can see this figure is give you details about the simple REST interaction between a user with a server, right? So you can see in the left part you have a client and the right part you have a server. And you know that the client is always requesting service to the server, right? And server is verifying the request and replying to uh, based upon your request, whatever resources you requested, that request is provided from the server to the client, right? So you can see how these things are going to done. We are using a web browser, right? A user is using a web browser in order to access the system. So in the web browser, we have HTTP or HTTPS. We are using HTTP in order to access it. After that, REST is there. So you may make a secure connection. You may go for normal connections as well, right? So these the client is going to request the services to the server through a HTTP packet, right? What is HTTP packet? In network also we have studied, sometimes you want to create a resource, sometimes you want to delete a request, sometimes you want to get some information, and sometimes you have to provide some information, right? So these things that is written here, sometimes we are using post, sometimes we are using get, sometimes we are using put, sometimes we are using delete, right? So this HTML packet will show you what type of information you are requesting to the server, right? So one client will be interested for the post, and then will be get, put, and delete based upon its requirement, right? So you can see here the this complete system. If you see, it is also used in the Google, Amazon, Yahoo, Facebook, Twitter. All the enterprises also uses this HTTP REST interactions, right, in order to request the services to a particular server, right? And authentication also plays an important role. We are using SSL authentication in the server side in order to secure the things, right? Okay, this REST architecture, if you see, the style is based upon the four basic principles. So you know that whenever we are accessing a website, we want the website address, right? Suppose I want to access our institute's website, www.nitw.ac.in, right? Then this website is converted to a particular IP address. Based upon that, the subsequent operation is done. That's why the first principle says that resource identification through uniform resource identifier, right? So it is saying each and every resources is located through a uniform resource identifier, which is a URI number. Or in a simpler term, you can say it is nothing but a look like a URL. Like you know that in distributed system, the resources are available all over the world. Suppose I want to locate a particular resource. How I can access the resource, or how I can make a request to that particular resources, that is through the uniform resource identifier, right? So this RESTful web services exposes a set of resources. We have a set of resources which identify targets of interaction with its client, right? Client's requirement may be satisfied with a particular resource or a group of resources. In order to locate each and every individual resources, what we need a uniform resource identifier, that is URI. So here resources does not mean that the resources is nothing but a document, it may be image, it may be temporal services. Like in Amazon S3 also, you have seen what kind of objects you can upload in the Amazon S3. It may be a document, it may be image, it may be any PDF file, or it may be a video file or image file, or you can say audio file, anything you can upload, upload, or you can request from a particular resource, right? So each resource is identified by a unique name that is called as uniform resource identifier, which is of type URL, right? And URI can be bookmarked and exchanged via hyperlinks. Sometimes what happens, like URLs also we are bookmarked, so that by the next time we want to access to the same websites, you can directly click and get the services, right? So similarly here also you can do what you can do, if you can bookmark the things and you can extend that thing via hyperlinks. If you see the second principle says that uniform and constrained interface, right? There are some predefined structures are there. We are using the predefined structures in order to request for a particular services, right? Like interaction with the RESTful web services is done by a HTTP standard. Okay, so it is done by the HTTP standard. You are requesting the resources through HTTP. and resources are manipulated using a fixed set of four CRUD valves for operation. Here CRUD stands for your C for create, R for read, U for update, and D for delete, right? So these are the four operations you can apply to a particular resources and manipulate a particular resources, right? So these operations can be possible, they can be provided through these commands. These are the more formal one in comparison to this thing, right? So if you are using put, why you use put? Put is used to create a new resource, right? Suppose I want to create a new bucket. So you are simply clicking somewhere, right? Clicking in the create bucket, you are giving the information. Based upon the information, the bucket is created in the Amazon S3, right? The same thing is done if you go for a command line interface, right? CLI command line interface. You have to use the put command if you want to create a new resource, right? Similarly, the next one is called as a get one. Suppose I want to describe the current state of the resources, right? Or your resources, maybe you can say anything, or you can say virtual machines as well, right? If you want to know the status of a particular thing, whether a bucket is filled or bucket is free, or bucket is preoccupied or bucket is full. So these things you can get the information about the bucket through GET command, right? So when you want to know the current state of a particular resources, whether the resource is BG or free or it is used by some other users, that information you can get from GET, right? The third command is used that is called as post. Post is used to transfer a new state onto the resources, right? So there is a movement of the resources from one state to another state, right? Like you have seen in operating system, there is something called process state diagram, right? The process is moving from one state to another state. Okay, it is moving from one state to another state in order to get the job done. Similarly, here also, whenever you are making a request, it may happen that it may move from one state to another state. So that is our post command, right? The next one is if you want to delete a resource, you can simply delete it, or you can use this command that is delete to delete the resources, right? So each and every services may be available through a command line interface or through directly by giving these commands, you can get the services. So REST the third principle is nothing but the self-descriptive language. In the self-descriptive language, you can use any language, but one of the popular language we always refer in service-oriented architecture, that is our XML. We are using XML, but early days HTML or these other languages like JSON, JPG, image, or PDF also. Varieties of formats are assessed for in our service-oriented architecture, right? So your message may be anything, but generally we are representing in the form of XML, but you can also use the JPEG image to transfer the data, or PDF file you want to transfer or plain text. So various of formats are supported by this REST architecture style, right? And in the metadata, we used to use for the case control, transmission error control, authentication, authorization, access control. Like one file is read write protected, or it is only read protected, or it will be write protected, or who can access a particular file. Okay, and what is the properties of that file, which content the person can view. Such type of things you can manage to the metadata option. The last principle is called as the stateless principle. Message does not depend upon the state of conversations, right? So that's why it is called as the stateless. In the service-oriented architecture, whatever message you are transferring from the client to the server, it should be stateless. And if you go for the stateless interaction, it decreases the network performance and increase the repetitive data, right? As there is no state, what happens, the data is, the network performance is decreased and the repetitive data is increased, right? That is the demerits associated with the stateless interactions. So REST supports these four principles. And the RESTful web services also can be considered as an alternative to SOAP. SOAP is a simple object access protocol, which is also used in the service-oriented architecture, which is an alternative of our RESTful services, right? Because RESTful web services, whatever things you are using, there is a restriction is there. For example, if you take the get length, the restriction is that the size should not exceed 4 KB data. Right? So 4 KB is very small, right? So you can use, instead of going for the RESTful services, you can also use the service oriented, simple object access protocol, not service oriented access protocol. It is simple object access protocol stack, and you use an alternative of the RESTful web services, right? Or you can say big web services also is an alternative for RESTful web services. So they are using some language which is called as a WADL, that is Web Application Description Language. So this language is, or you can go for, I will also discuss about WSDL, right? This WSDL language, these two languages are nothing but written in the form of XML, that is extension markup language vocabulary to describe the RESTful web services. Okay, but REST is not a complete standard. You can also see JSR 311 or JAXRS. It defines a set of Java APIs for the development of these RESTful web services, right? So these things are used, and they are also providing the mapping between the URL and resources. So whatever the resources infrastructure is available in the cloud, right? Each and every resources is represented from the URL. The mapping of the URL to the resources, right? Like you have to locate a particular resources, you require IP, right? Internet your IP address, right? Through IP address, you can locate a particular resources, right? So the mapping of these resources with URL is provided by JSR 311, okay, which is required in the RESTful web services. RESTful web services is also used in the Amazon S3, which we already discussed. Right, in Amazon we have objects, we have bucket, we are creating multiple objects inside the bucket. Similarly, you may have several buckets as well, right? We created a single bucket, but one person can create more than one bucket, right? More than one bucket or more than one object inside each and every individual bucket, but each and everything has a unique, each object has a unique and a URL. Through that URL, you can access to that particular object or bucket, right? So there are three types of resources. That is, one is your bucket, a list of user bucket. With respect to your user, you can maintain, or your user can have multiple buckets. And the second thing is a particular bucket, right? You are specifying a particular bucket. Third is a object inside the bucket. First one is a list of users who are using the buckets, where a single user can use multiple buckets. Second one is a particular bucket we are interested for. Third one, in a particular bucket, we have several S3 objects. So based upon that, what you can see a particular URL here. It is maintained as https://s3.amazon.aws.com, followed by the name of the bucket which you are interested for, / the name of object. So whenever you access the Amazon S3, you have noticed this thing, that suppose you are giving your name of the bucket is your name followed by your mobile number. So that is your bucket name, and name of the object. Okay, name of the object is which suppose I have uploaded figure 01 into a particular bucket. So this object name is our figure 01. Okay, you can see the various elements that are available in the REST. One is the data element, another is connectors, another is components. And their examples, the elements inside the data elements is your resource, the resource identifier, which is nothing but your number, that is representation metadata, resource metadata, and control data is there. And the connectors are nothing but the client is there, server is there, in between the client and server, cache is there, resolver is there, one tunnel is used, which uses our SSL to secure the channel, right? So they are respective with respect to their element. The example is also listed here, right? So these are the various architectural elements available in REST. Okay, Amazon S3 is providing you the same thing what we discussed. One is your get. If you want to get is used to list buckets created by a user, right? So this is a command line. When you go for the command line, you can use it, right? But in Amazon S3, we use in a drag and drop basis. So whenever you are clicking a particular thing based upon your requirement, one of the commands is executed, right? for example, you want to list the buckets created by a particular user, you want to see, that is nothing but the get command, right? If you want to create a particular bucket, you can use put, and if you want to remove a particular bucket and object, we are accessing the delete one. And if you want to get a specific object's metadata is nothing but whenever you have explored the object, okay, when you click an object name, then it is created, what is the size of the object, and what is the URL or URI of that particular object, and everything is fine. So if you want to get that metadata, that is nothing but you are invoking the head command, right? So by the help of that, you have created a bucket and you make a object or your bucket is public one. Third is you have developed a bucket policy. Fourth one, you have explored the versioning part. Fifth part, you have seen whenever you have explored the versioning part, you have also seen that whenever an object is deleted, how you can retrieve that object and how you can extract the object that is there we have studied one concept that is called as delete marker, right? So by the help of delete marker, if you delete from that, then again the object will be restored to your bucket, right? So creating new buckets we have studied, upload buckets also upload objects, multiple objects inside a particular bucket also we have seen, and we are deleting an existing bucket and the objects also we have seen in Amazon S3. So here you can see whenever you are going for such bucket creation, so S3 invokes REST, right? REST to provide such services. So how REST is doing this? So there are two things is written here. You can see in this particular table. One is called the REST request, right? REST request is nothing but put command. That's why I told in the previous slide that if you go for put is used to create in a bucket. So whenever you are making request, if you are using put means you are interested to you are requesting the S3 means Amazon Web Services to create a new bucket, right? So put is used, then bucket name is used, right? Bucket name as for your requirement, and it should be a unique one, you know that one, right? If you use the name of the existing bucket, then the bucket will not be created. And you are using HTTP 1.0, and what is the date? Some date at what time you make the request, the time in the GMT. Authorization also given, because whenever you are creating a student account or learner account in Amazon Web Services, you are assigned with this AWS access PID, right? So this AWS PID you have to give while you are making this REST request and other signature, right? So all the messages is divided into two parts. One is first part is your header information, okay, and the part is your body information. The detailed information is available in this body part, and some important information is available in the header part. Like email, we are writing subject, right? We are writing subject, that is the, you can say abstract kind of things, or we are writing 5-6 words you want to say what is there inside this email, and the complete message you are writing in the body, right? So in this way you can making the REST request, or whenever you are clicking or creating the bucket, a put request is generated with these details in order to create a bucket in Amazon S3. In response to your request, there is a REST response as well. A REST response is like this. So it is accepting your request and is creating a bucket in a particular locations. You can see it is creating in a particular location in Amazon S3. You see this location will be US East, this location will be US West, or it may be Asia Pacific, it will be other regions. So based upon that, this bucket is created, and the length of the bucket initially if the content is 0 and connection is active. So these are the things that is maintained in the REST response. So to authenticate, first whenever you are making a particular request with your AWS access PID, okay, this PID element identifies the secret key in order to compute that whether the user is a genuine user or not. So if the requester signature matches, right, whatever access ID you have given, based upon that we are generating the secret key, and if it is matched with the signature, when the request is authorized and subsequently the request is processed. Right? But if you are not an authorized person, then the signature mismatch will not really happen, so that security violation will not be there. Right? So before proceeding something what we have to do, we have to see the AWS SSPI in order to generate the signature. Right? Then only we can match the signature with the existing one, right? If it is matched, then you are authorized user. Otherwise, you are not an authorized user, so simply the request is blocked. So in SOA paradigm, software capabilities are delivered and consumed by loosely coupled, reusable, host-brain, discoverable, and self-contained services interacting via message-based communication. Although different modules are there, the process is making simpler using the service-oriented architecture. So what happens? Each and every units, they are sending messages between each other in order to fulfill the services. Right? As I told you also that Amazon also provide SQS, that is simple queue services, which provide the reliable messaging between two different units. So such type of connections can be provided between the components in order to provide the service more securely. So next, coming to the web services is referred to as self-contained, self-describing and modular applications. So whenever you are invoking a particular website or whenever you want to get a particular service, basically you are invoking the web services, right, which is represented by WS. I'll tell you detail about what are the web services available on the service-oriented architecture. So web service is a software system designed to support interoperable machine-to-machine interaction over the network. Okay. So while you are invoking, you are requesting a REST request that we discussed to a particular computer system. That computer system will communicate with other systems, right? If that system is not capable to do it, it will again communicate with the other system, or it will forward the request to other system. Finally, it will come to the client's computer system in order to deliver the work. So there, if you see, once the user interaction is there, the REST interaction is machine-to-machine interaction, right? That is the overall network. So web services has an interface described in a language that is called as WSDL, Web Service Description Language, which is again a XML-based language which is used in the web services in order to provide an interface or in order to design a particular interface. So here you can see a service requester is getting in the right side and service requester is making a request to the service provider, which is called as simple object access protocol request. SOAP request is made by a service requester to the service provider. So finally, what service provider will do? Service provider will do the necessary things. They will see the status, or they will check that whether the service requester is means the right person to get this particular service or not. If it is satisfied, then what to do? It will provide the response. SOAP response in view of your SOAP request. If a request is made, based upon that, it will make an SOAP response, right? So you can see here one interesting unit is there, which I told you in the very beginning. It is a UDDI, right? Why UDDI is used? It is a replicator, or you can say it is a registry, which keep up the information of each and every request and information, right? So this UDDI repository maintains nothing but the various XML files. That is nothing but the WSDL, that is web service description language. So what happened here? You can see user also may query to find a particular service. Suppose I can ask UDDI registry that where I will get this particular web services. Such kind of query also I can ask to UDDI. UDDI will refer to the WSDL document. Based upon that, it will give you the details by the WSDL document which contain the information about the particular service, right? So the document, what is the WSDL document, also can be provided by UDDI to the service requester. So the service requester will come to know what kind of services and where it is going to ask for that particular services. Similarly, you can see between the UDDI and service provider, you have publish and update service description. In each and every service, whatever provided by a service provider, the information need to be updated in the UDDI repository. So you can say UDDI repository is a intermediate person in between the service provider and the service requester. So it has information about the provider and the service requester. So whenever a requester make a particular request, what it is doing, it is making a matchmaking process, and based upon that, it is providing the information to both the providers as well as the service requester. So yes, that is simple object-based protocol provides a standard packaging structure for transmission of external document over various protocols. So protocol may be, you can say, HTTP protocol, or it may be simple mail transfer protocol, or FTP protocols as well. So SOP message is consist of a root element, that is envelope, like just whenever we are writing a particular letter, right? So we are keeping that letter inside an envelope, right? So what the similar kind of things we are doing in SOAP. So here we have an envelope which contains two things. One is the header part and one is the body part. Header part means it contains the routing information, because whenever it is the information is traveled in a particular network, it is moving from one unit to another unit, one component to another component, or one device to another device, which require your routing information, authentication, transaction management, message parsing instruction, quality of service configuration. So these informations are available in the header part, and rest information, the detailed about a particular message, that will be called as payload. In the network term, we have also studied payload, that is available in the body part. So an envelope consists of two parts. One is header and body part. Header contains the important information, how the packet will reach to the proper resource, and the body contains the details payload about the particular message. And the content of the payload is marshaled, unmarshaled by at the sender receiver side, right? It is marshaled at the sender side, marshaled by the sender side, and it is unmarshaled at the receiver side, so that the receiver can read what kind of message the sender has sent, and what kind of information the sender require from the you can say from the server, that information can be provided. Here we are using the WSDL language. WSDL language describes the interfaces, a set of operations supported by a web service in its standard format. Right? So WSDL is like XML. We are writing XML/XML. We are writing WSDL/WSDL, and we are also in the component that what information is available in the header part, what information is available in the body part. And WSDL also standardizes the representation of input and output parameters. Whatever the parameters is required, it standardizes. So it's like get, put, and commands are there, right? Whatever the delete command is there. So similarly, so the input and output parameters are already predefined. So that standard values is used in the WSDL language. Yes, here we are using UDDI. I told you that it's universal description discovery integration. It provides a global registry for advertising and discovery web services. So it is keeping both things. This UDDI contains both things: information of service provider and service requester. That's why we call that one, that is it is advertising and discovery of services. Advertising for the service provider, and it also helps the requester to get the services. That is called the discovery of web services. SOAP is an extension and evolved version of the XML RPC. XML RPC is Unit Procedure Call, which was introduced in 1999. So SOAP is a better modified version of, you can say, XML and RPC. XML schema got W3C recommendation in 2001. After that, it became popular. And instead of using this RESTful API or web services, what you can do, you can also use this SOAP-based web services. Okay. It is also referred as big web services. SOAP-based web services provides synchronous as well as asynchronous services. It also supports your both request response or your message. Sometimes what happens, the message needs to be passed the one unit to another unit, where we require a one-way message pattern. We do not require any kind of acknowledgement, right? So in that case, we can go for one-way message patterns, or sometimes you need the information from the receiver as well. There we will go for the request response, right? And WSI protocol stack, various services are web services are provided, and they have a protocol stack just like our OSI ISO reference model, or just like you can say our TCP IP model. Similarly, here WSI protocol stacks are there. And if you go for the RESTful web services, it do not cover the quality of services and contractual properties, right? These things are not well covered in the RESTful web services. But when you go for the SOAP based web services, these things you can get, which is not there in the RESTful web services, right? So you can say SOAP is providing better services in comparison to the RESTful web services, where web services commission. Message communication and reliable transactional policies, like you can see, WS security is there. Suppose somebody is required a service with respect to the security. So I told you in the beginning slide also WS hyphen star, right? So the star may be anything. The star is maybe anything, right? Star may be with respect to the security. It may be agreement, it may be reliable messaging with respect to the transaction or coordination. So what kind of services a client requires? Based upon that, that web service can be delivered to that particular client. So let us see the protocol stack. This is a complete protocol stack. You can see starting from the processor and composition. In process composition, we are using BPEL4W. The full form of BPELW is Business Process Execution Language for web services. This is a XML-based language which build top of the web services, like we are using web browser, right? That is the top part, and WS notifications are there. Web service based notifications. In order to maintain the quality of services, also various web services are there. Quality of services is referring to the security. It is also associated with reliable messaging or resource lifetime. And various description about the web services is provided by WSDL language, VDI repository, because VDI is an intermediate between service request and service consumer. WS policy, WS resource properties. Similarly, for the messaging, we are using SOAP service simple object process protocol, or you are doing for WS addressing, WS transaction, WS coordination is there. In the bottom part, you have the protocols like STTP, SMTP, FTP, which require to communicate from one component to another component. So you can see in the grid computing, we are using a very popular factor, the popular tool that is called as the Globos Toolkit 4. And the advanced version is also there, that is Globos Toolkit 5. So such type of architectures are also used in this service-oriented architecture, right? So SOA is not service-oriented architecture is not limited to cloud; it is already there in the grid computing architecture. And one important point is listed here. You can see that transmitting of data using XML leads to a considerable transmission power. Okay, and that if you see the factor, the transmission overhead factor, it is around 4 to 10, right? That's why many people are heading towards the web services, which is, you can say, instead of using XML, it's advanced one, that is WSDL language. It's used instead of XML, so that web services can be composed together to make more complex web services, and this factor can be reduced, right? The amount of transfer factor, which is 4 to 10 in the case of XML, it can be reduced. So this is the details about the SOAP request. You can see there is an envelope, right? The envelope consists of two things. One is the body part, and then there is the header part, right? This part is the header part, and this part is the body part. And each and everything is represented in the form of a tag. It may be a singular tag, or it may be a, you can say, it is paired tag, right? You can see here, you are writing SOAP envelope, okay? SOAP envelope, and at the end we are writing SOAP envelope plus SOAP envelope. Similarly, body is started here and body is ended here. Here our objective is to create a bucket, okay? So create a bucket, and we are writing slash create bucket, and the detailed information how to create a bucket, what is my AWS SSP PID that I need to mention. So that's why we're representing this as a by WS star. Okay. So all types of services will come under WS hyphen star. It may be reliable messaging, it may be notifications, it may be your authentications, it may be authorizations, it may be reliable messaging, it may be anything, right? So WSRM, if you see, is a reliable messaging. Uses the message instance count to allow the distribution services to represent a message delivery for either missing or out of order messages. So reliable messaging is only focusing on how efficiently you can communicate between two different units. Okay. So it is identifying whether there is any faults with respect to the messaging that can be identified by this particular web service. And these are the specifications area. For example, if you need the core service, you can use the WSDL or SOAP. If you want to go for notifications, somebody require notifications, they can invoke the WS notification. Okay, somebody require, let's say, policy and agreement. In that case, WS policy and WS agreement is there. So based upon the specifications or specification of the requirement of a particular customer or the user, the corresponding WS web services can be provided.